This is the homework helper for Chapter 11, Section 5 in the 8th grade workbook, Solving Multi-Step Inequalities. So as you can see, the top part here is all about me solving an inequality and graphing. So I'm going to go ahead and work down the right column with you there and work through 2, 4, 6, and 8 with you. In number 2, we've got 6 minus 1/5 y is less than or equal to 7. So as far as me solving that goes, we know we want to keep that variable y on the left and send numbers like 7 to the right. So we see the two things we don't like here are the 6 and the 5th. We know that the thing that's directly connected to the variable always goes last. So since a 5th is directly connected to y, he's going to be the last thing to move, which means 6 is going to go first. Remember, when I'm moving something to the opposite side of the inequality sign, I do the opposite. So I'm subtracting 6 all the way across here. And when I do that, I end up with negative 1/5 y is less than or equal to 1. Well, now this is a multiplication inequality. So I'm going to solve this by dividing. But look at what I have here. I have a fraction. I've never, ever, ever divided by a fraction. We don't even do it when we're doing equations, more or less, inequalities. We don't even do it when we're just working with two regular old fractions. Forget the equation or inequality part. Forget the variable. So if I'm dividing by a fraction, what I really mean is to solve here, I'm going to multiply by the reciprocal, what I get when I flip that fraction. So what I'm going to do to solve here is multiply both sides by negative 5, which is the reciprocal of my fraction here. If I flip this around, it would be 5 over 1. Of course, I don't have to write it as 5 over 1, though, because we all know 5 over 1 makes 5. All right, now notice what I am doing here, though, is I am multiplying by a negative. And remember, that little rule says when we multiply or divide by a negative, flips the inequality sign around. So I do want to make sure I flip the inequality sign around here. So that's going to give me y. It's now going to be greater than or equal to, and it's going to be greater than or equal to negative 5. So that's what I've got to make myself a quick little graph of. So let's make that graph. Close dot on negative 5. Why close? Because it's one of the ones that has the line underneath it. Y on negative 5 because that's the only number in my inequality now. So close dot on negative 5. And then I have to shade. The shade shows all the solutions that are represented here in the inequality form. Well, if I'm saying the numbers that are bigger than negative 5, those are numbers like negative 4, negative 3, negative 2. Then on my positives, where are those? Those are to the right of the dot, so we shade to the right. Remember, as long as we put the variable on the left side of the inequality sign, my shading always matches the same direction as this sign points. Now, in number 4, we've got 10x is greater than 2 times 7x plus 3 in parentheses plus 2. There's a lot going on here, but what's most important to us right off the bat is distributive property, because we have a number in front of a set of parentheses. When we have a number in front of a set of parentheses like that, that means we need to multiply that number through to the things that are inside the parentheses. That's what the distributive property does. So let's distribute here. So I'm going to distribute the 2 through to the 7x and the 3. So the 2 through to the 7x, that's going to give me 14x. 2 through to the 3, that's going to give me 6. I have the plus 2 at the end here, and the 10x in the beginning. All right, now this isn't too bad, because if we go by our rules, I have a variable on the left, and I got a whole bunch of number things on the right. Well, what we can do here is we can combine some like terms. What I want to do is go ahead and slide that 14x over to the left side so I can get some like terms together here. So I'm going to go ahead and subtract 14x from both sides here. Now that I've done that, now I have negative 4x is greater than what equates to, we're going to simplify this as well, 6 plus 2, which is 8. Well, you were waiting for me to say, well, why don't we leave that 14 there? I have to simplify and combine my like terms before I can slide those numbers over to the right. As you can see, it's not 14 anymore. When I combine my like terms, it just went down to a 4. Now I'm going to slide the 4 back over to the other side there. All right, so that means me dividing out here by negative 4. Now, of course, if I'm dividing by a negative, as you saw in the last question when I multiplied by a negative, that flips the direction of the inequality sign. So it's not going to be greater than anymore after all that work. It's actually going to end up being less than. X is less than -2. What do? Well, we put an open dot on -2. It's open because it's one of the ones that does not have the line underneath, and then we shade from the dot to the left. Number 6 is k over 5 plus 3 over 20 is less than 3 over 10. So common denominator land here is 20. How do I know that? Well, I do the least common multiple of the denominator. 5 list is going to go 5, 10, 15, 20. 20 list starts at 20, so I don't even have to touch that fraction. The 10 list goes 10, 20. The match happens at 20 here. So when I have fractions, just like you saw in the notes, I'm going to go ahead and write these with a common denominator, and my common denominator here happens to be 20. So middle fraction isn't even going to change in this process. It's only the front fraction and the back fraction that are going to need to change here. Now with the first fraction, since it was already had a denominator of 5, to change that into a 20 means I'd be multiplying by 4. So I'm going to multiply the numerator by 4 as well. That's going to now give me 4k's. With the fraction in the back, to change 10 into 20 means I'm multiplying by 2. So I'm going to multiply the top by 2 as well. 3 times 2 changes into 6. All right, so since we have a denominator of 20 here now, I'm going to go ahead and multiply the whole line by 20. And that's going to cancel this out with all those denominators. And it's going to leave me 4k plus 3 is less than 6. Solve. Well, if I'm solving that here, I know I need to send numbers to the right side. That means I know I need to send 4 and 3 both to the right side of the inequality sign. Well, we know that the thing that's directly connected to the variable goes last, which means 3 has to go first. So let's move the 3. So I'm going to go ahead and move the 3 by subtracting 3 all the way across. That's going to give me 4k is less than 3. And then I'm going to solve that multiplication inequality here by dividing across by 4. And that's going to give me k is less than 3/4. Solving then, go to my number line. I'm going to put an open dot on 3/4, which is close to 1, but not quite there. And then shading is going to take me from the dot to the left. All right, number 8 is another fraction question. We've got 2/9 plus y over 3 is greater than 1/3. So again, I want to go ahead and get a common denominator here. Common denominator hits at 9. 3, 6, 9. 9 starts at 9. The match is at 9. The least common multiple of 3 and 9 is 9. That's how I know the least common denominator is 9. So I'm going to write all of these with fractions over 9. That means fraction 1 doesn't even have to change, but fractions 2 and 3 absolutely do. To change 3 into 9, we're multiplying by 3. So I'm going to multiply this by 3 as well. That's going to give me 3y. To change 3 into 9, we're going to multiply by 3. So I'm going to multiply the top by 3 as well. That's going to give me 3. So now what I'm going to do is multiply the whole line by my common denominator 9. And that's going to cancel that out with the denominators and leave me 2 plus 3y is greater than 3. All right, so as far as solving goes, we know we like variable y on the left. We know we like 3 on the right. That means we don't like the 2 and the 3 that's on the left. Both of those being numbers have to get kicked over to the right side of the inequality sign. Since we know that the 3 that's connected to the y is going to go last, because what's connected to the variable always goes last, that means I'm going to move the 2 first. So let's talk about moving the 2 here by subtracting 2 from both sides. Again, me doing the opposite as we're used to. And then since this is a multiplication inequality, we're going to solve that by dividing across by 3. And when I do that, I get y is greater than 1/3. Make myself a quick little graph here because that's what the directions asked me to do. That's an open dot on 1/3 on the graph, close to 0, but not all the way there. An open dot shading to the right. All right, let's look at number 10, the story problem, which is also the concluding question here. It says Jack wants to run at least 275 miles before the season begins. He's already run 25 miles. He plans to run 2.5 miles each day. At this rate, what is the fewest number of days he will need to reach his goal? So if he wants to run 275 miles, but he's already run 25 miles, that of course means he only needs to run 250 miles still. Now the question says he's going to run 2.5 miles each day. We don't know how many days that is, but we know in order to get there, he's going to have to hit 250 doing so, or go over as the case may be. So what we want to say here is that 2.5 times x. Why 2.5 times x? The number of days is what we don't know. That's what the variable is, but we know he's going to cover 2.5 miles on each of those days. So we're going to say 2.5 times x is how I'm going to get to 250. Now, the question says at this rate, what is the fewest number of days he will need to reach his goal? Well, he can get to exactly 250 and be there, or he can get to anything bigger than 250. Even though we're going to solve the inequality to say something like x is greater than or equal to 300. It's not 300, but we're going to solve it. 300 then is the fewest number of days he could reach that goal in. He can do it more than that, but that's not what the question is really asking me. It's what's the fewest number of days he can get that done in. Well, this is a very basic one-step inequality. And of course that means we're going to solve by dividing. Dividing across by 2.5 to keep x by itself on the left side. And that's going to give me x is greater than or equal to, in this case, 100. So that means, in context of the question, the fewest number of days he can accomplish his goal in is 100 days. He can do it in, he can cover more than that in that amount of time, but it's going to take him at least 100 days to do that, to cover his goal of distance.